For your warm-up today, you're going to expand each power of 10. With this one as 10 to the 10th, we should have 10 zeros or 10 place values after our initial number. Then we would want to group them in sections of 3. So you can think of this as 10 billion. Archimedes was a Greek mathematician whose ideas were ahead of his time. He lived in Sicily during the 3rd century BCE and was the first to develop fundamental concepts in geometry, calculus, and physics. Fascinated by very large numbers and living on the coast of the Ionian Sea, Archimedes set out to determine how many grains of sand are needed to fill the known universe. Mathematicians used Ionic Greek notation in the 3rd century BCE. So instead of numbers, they used symbols and letters from the Greek alphabet. Each of these symbols has a name and a value associated with it. In this system, these symbols represent the number 654. What do these symbols represent? So looking at this first one, looking for that symbol, we see it is sigma, which represents 200. This next symbol is called pi, which represents 80. And then the third symbol is epsilon, which represents 5. So this would represent 285. See if you can determine what the next one represents. Use the table with the symbols and values to determine what these symbols represent. This is 777. Number 3, read the story of the death of Archimedes. Then write the Greek math symbols as numbers in the blanks that follow each number. Because the exact details of his death are not confirmed, this story is one of the many theories about how Archimedes died during the Second Punic War. The story begins. Archimedes' native city of Syracuse, Italy, was captured by Roman forces in the year. Look at your table and fill in the blank with the number that matches it. While the city was under siege, Archimedes was drawing a diagram of circles in the sand. As he contemplated his work, the blank-year-old mathematician was approached by a Roman soldier demanding that Archimedes meet immediately with the general of the Roman army. Archimedes refused, insisting that he would not go until he finished his math problem. This infuriated the Roman soldier, and he pulled out his sword and killed Archimedes on the spot. Fill in the blank with the age of the mathematician. Archimedes' last words are thought to be, "Do not disturb my circles." His work would go unknown until the year blank years after his death. Go back to the table and figure out which years these represent. Another way that you can rewrite numbers instead of using the symbols is what's called scientific notation. In scientific notation, you get a whole number multiplied by a power of 10. This initial value, or this first number, has to be a single digit. So here we have 6.02 times 10 to the third power. The 6.02, you can see there is one whole number in front of the decimal, and the rest falls after the decimal. Here it says to fill in the blanks to complete the statement. A number is written in scientific notation when it is represented as a number A multiplied by what we call a power of 10. It's a 10 with an exponent. The general expression that represents a number written in scientific notation is A, that number, multiplied by that power of 10. And we use n to represent the power. The absolute value of A must be at least 1 because we want a single whole number, but it has to be less than 10 because 9.99999 is less than 10 and it has that one whole number in front of the decimal. Identify the first factor and the order of magnitude of the expression. The first factor is that A value, which in this case is 8.86. The order of magnitude is a fancy way of saying the exponent, the power on the 10, which is 6. Here, the order of magnitude would be 3, and the first factor would be negative 7.1. Looking at this list, we're going to go through and mark off which ones meet the requirements for scientific notation and which ones do not. This first one has a single digit times a power of 10, so that is an example. However, this one is not between 1 and 10. It's not 1 or bigger. It's less than 1, so that is considered a non-example. 715 has more than one whole number, so that is also a non-example. It is not in scientific notation. 4.8 is between 1 and 10. It has that single digit times the power of 10, so it is an example. 19 is larger than 10, so it is not an example. This negative 6.75 is okay because its first value or initial value has an absolute value between 1 and 10. If we took its absolute value, it would be 6.75, which is 1 or bigger and less than 10. The next one is also an example. However, this one has 2 place values before the decimal, so it is not an example. For problems 7 through 9, write them in standard form. The way that I write them in standard form is I look at my number here. There's an invisible decimal after the 3, and this order of magnitude tells me how many place values to move the decimal. So 1, 2. And in that gap, I fill it with zeros. So my answer here would be 300. For 4.8, I need to move it 3 spots. 1, 2, 3, and fill in those gaps with zeros. So the answer here in standard form would be 4,800. This one needs to move 6 positions. 1, 2, 3, 4, 5, 6 positions, and fill in those gaps with extra zeros. So this is 6,750,000. You can also use the place value chart to help you. This would be 9.1, and we need to move it 3 spots. So the 9 is going to move 1, 2, 3 positions. So now I have 9 and a 1 followed by 2 zeros. You don't need additional zeros after the decimal, but it's not incorrect if you place them there. Here I have 2.05, and I need to move it 6 positions. So 1, 2, 3, 4, 5, 6 spots. So now the 2 is here, and the rest of the numbers follow behind. So this is 2,050,000. Logan writes the number 6.7 times 10 to the third in standard form. He writes 67,000 because 10 to the third represents thousands. This piece is a true statement. Do you agree with Logan? Explain. His answer is incorrect because it is 6.7 times 1,000. So it should be in the 6,000s, not the 60,000s. He moved 4 spots and has an additional 0. His answer should be 6,700. Write this number in scientific notation. We get one whole number, and then the decimal has to come after. We don't need to write all of the zeros, but if I place my decimal here, that leaves me with 5 place values behind it. So our exponent would be a 5. Here I have 350. So if I wanted to change it to be 3.5, that moved the 3 2 positions. So it would be 3.5 times 10 to the second power because I had to move 2 spots. For this number, I want a single number, then the decimal, and then the remaining numbers. I don't have to put in all of the rest of the zeros. After the decimal, I have 3, 6, 7 spots. So my exponent, or my order of magnitude, should be a 7. For this one, a single number, then the decimal. There's 3, 4, 5, so it should be 10 to the 5th power. For this one, we have 6, then the decimal. We need to go 0 and 4, but we don't need the rest of the zeros. If I put my decimal here, that leaves me with 3, 6 place values. So it should say 10 to the 6th. It may be helpful to write out 36,380 or 360 as a regular number before you convert it to scientific notation. If I place my decimal there, that's 4 place values after the decimal. Think about some of the characteristics of scientific notation. We use that X to represent multiplication. We have a power of 10. We have a single digit that's between 1 and less than 10. And it's also helpful to write things in scientific notation when we have really large numbers or really small numbers. Check back in soon. I'm trying to post more videos to be ready for you guys.